I will start just, you already did the introduction of ourselves. So my name is Javier Alonso and Carlos Roces. We are from the sales department here in FELEMAG, North Spain, as you said. And I will introduce my colleague Carlos will do an introduction about the company, how started this company in 1970s, what we do. And after that, I will explain some of our products for the people, just to show a rough view of different products, not all, because we have different types of products, even products specifics for customers, but the most important devices that we manufacture, just for your information. So I will let my colleague Carlos to do the introduction of our company, okay? Carlos, te dejo.
Okay. My name is Carlos Roces. I have worked in the sales department of FELEMAMG for 21 years. First of all, I would like to thank this chance to explain our experience and so on our company to you. I will start with a brief introduction about the beginning of the company and its evolution. I would like to share a video where you can see what we manufacture and different applications while I'm speaking about the company. One moment. I hope to do it. Okay.
So down in the bar, okay.
You can see the video now.
Yep.
Okay. First, I would like to speak about my personal experience. I graduated in university in a Bachelor of Engineering in the field of electronic. And after 2 years, I was working for a company related to electrical industrial assemblies. I obtained a job interview with FELEMAMG, and it was good. And in a few time, I started working here. Our work into the sales department consists in a close contact with the clients. They call us, usually they call us with a problem which they want to solve, and we try to give a solution with some of our products. These projects includes a first technical advice with a visit or a virtual meeting, and after that we study the project and propose to the client a technical solution, which may be with a series product or with a new product designed especially for his case. This proposal includes a technical part and one economic part too, with all the prices and the conditions. If this project is carried out, we continue with the project all the time. This includes a lot of mails, phone calls, documentation, manufacturing reports, drawings, and so on. After that, I hope you have a notion about our job. I would like to continue with a general explanation of our company. Before to continue, it's very important to know that our manufacturing can differentiate to two big fields. The magnetic lifting, used to handle transport heavy loads, very used in the steel plants or foundries, and magnetic separation, to separate ferrous metals or non-ferrous metals for another kind of materials. Apart from these products, lifting magnets or separation magnets, we also manufacture other products as a special application, but they are a very lower portion of our total manufacturing. FELEMAMG is a company situated in Gijón, in the region of Asturias, in the north of Spain. It's a very industrial zone into the steel sector, with different important companies like, for example, ArcelorMittal with two big steel plants close to us. Due to the great demand, of the Spanish steel industry at the end of the 60s or 70s, for new magnetic equipment and for the repair of existing electromagnets from different world manufacturers, European and American too. FELEMAMG began in 1970 as a workshop, specialized in repair of electromagnetic equipment, especially round and rectangular magnets for lifting loads. At the beginning, we had a great success with our electrical coils. They were very resistant to failure, and the market began to ask for our own products. We start with lifting magnets, and around 1974 or 1975, FELEMAMG started to manufacture electromagnetic separators, very used in several fields as mining, recycling, foundry too. Until that date, all magnets used for lifting and separation were electromagnets with an electrical coil. But in a few years, around 1982 or 83, we start to manufacture magnetic separators with permanent magnet. First with ferrite blocks only. In 1989, FELEMAMG manufactured its first high-intensity electromagnetic separator for the mining industry, for cleaning sands, mainly feldspar and quartz. And this is the more powerful machine that we manufacture, with a magnetic field of 21,000 gauss. In 1991, we start to use permanent neodymium magnets to manufacture medium and high intensity magnetic separators, usually to purify ferrous minerals. And at the same time, we also began to manufacture the first non-ferrous metal separator, usually called eddy current separator, mainly used to separate aluminium or copper. In 1990s, magnetic equipment called ELECTRO-PERMANENT magnets began to be manufactured and used. These magnets are a combination of an electrical coil and permanent magnets, and they are used for lifting loads with a maximum security, because they don't depend on an electric supply to attract the load, avoiding the alternative system of batteries necessary when electromagnets are used. In recent years, FELEMAMG improves the current separators, starting to manufacture eccentric ones, and also introduce the transversal system for the separation of fine materials and very fine of non-ferrous metals. Our research and development department is continuously studying and testing new magnetic equipment for industry. Later, my colleague Javier will explain better these systems. The last 50 years, our products have been providing solutions in nearly all production sectors in over 30 countries. The experience and dedication of these years with our clients' acknowledgement has placed us among the main European manufacturers in the field of magnetism. We try to use advanced technology and the best means of production to do our work and provide a wide range of magnetic products, always designed with a standard of safety and quality. Our main aim is the total satisfaction of our clients. In reference to our presence around the world, currently we have several sales agents in different countries. For example, in America, we have several sales agents in Mexico, Peru, Colombia. In Europe, Norway, France, Portugal, and Taiwan and Indonesia in Asia. Our products have been sold and still are sold around the world for more than 30 years. And now I'll give the floor to my colleague, Javier Alonso, that will explain all our products. Thank you.
Hi, hello. Can you hear me now? Hi.
Yes,
Hello?
yes.
Okay,
Yes.
hi. So, okay, thank you, Carlos, for your explanation about the beginnings of FELEMAG and the situation, the current situation of our company. As you said, I will explain roughly some of our equipment. I have here a presentation. I'll try to share with you also a presentation I have here to show you some of the devices that you already have seen in the video of Carlos. I'll try to explain a bit some of them. Just 1 second. I'll try to share the screen. Okay. 1 second. What's the problem? 1 second. And now, can you see the screen right now?
Yes.
Yes. Okay. Okay. So, okay, that's our company here. As my colleague said, we started in 1970 to manufacture magnets. Here, the situation here in Spain, north of Spain. Okay. So, and these are some of our customers. Here you can see some of them. We have many others also. As Carlos said, we have a solution, a standard solution, but also we have a solution specifics for the customer when they need some solution, a magnetic solution. Okay. I want to explain a bit, as my colleague said, that we have like 2 different fields inside the magnetic manufacturing. Magnetic separation. So I will show some information about overband separators, both electromagnetic and permanent magnet overband separator, electromagnetic drums, permanent magnet drums, eddy current separator, high intensity with permanent magnets and high intensity with induced rod, electromagnetic high intensity. That's what my colleague said, that is the one more powerful that we manufacture. Okay. Also, I'll speak later about magnetic lifting equipment, such as round electromagnets, rectangular electromagnets for handling plates, electropermanent magnet. I will show or explain a bit the difference between electromagnet and electropermanent magnets also, and some images, some explanation of special electromagnets that we have for different applications. So I will start here. If you have if you don't understand anything I'll say it or whatever, you can just ask to me or tell me to repeat if you don't understand or you want a further explanation of anything. Anyway, at the end, I can leave some minutes if you have any doubt. Okay. So as you can see here in these pictures, the overband separators, this one is electromagnetic, this one is permanent magnet. They are very similar externally. Internally, they are quite different because one is using the permanent magnet is using permanent magnets, as the name says, to produce the magnetic field, and this one is use a coil to produce electromagnet. Here you can see that the overband separator are installed above a conveyor belt normally, across the conveyor belt here, as is shown here, or at the end of the conveyor belt, what we call in line with the conveyor belt. And you have here two drums, the driving drum here and the tail drum, and a belt that is moving around to extract the magnetics. So I'll show you here, as you can see, an overband installation. Here you have a cross installation. This is the conveyor belt with material, or in line. That's electromagnetic and permanent magnet. The installation is the same. So when the material enters in the field of the magnetic separator that is produced by the magnet that is here, it is attracted towards the magnet, and with a belt with some ribs, that drag the material out of the magnetic field and outside the belt, so you can recover here all the magnetics that pass through this material. This type of overband separator are very widely used in different sectors, like mining, for example, to protect the belts. They have normally very long belts that is very expensive to replace them. So they want to take out any iron, big parts of iron that may be there, that they may broke the belt, to protect mills also, for example, also inside the recycling industry, also for cans, for example, or many other different applications. Okay. Another type of separators are the drums. That can be a magnetic drum, permanent magnet drum, or electromagnetic. These two are permanent, for example, and these two are electromagnetics. They are normally installed at the end of the conveyor belt, and it can be supplied. For example, this one is supplied with a vibrating feeder in order to open the material as much as possible. You have a housing here, and the magnetic drum will be here inside where the motor is. So the materials arrive on the top of the drum and goes out in this way, the magnet is on that way, and the what we call inert material without magnetics on the other way. I'll show you better that later. Here you have here an explanation how it works. It's quite simple. Here arrive the materials. For example, this one is on the head of the belt. The magnetics is the black things. They are attached to the magnetic drum, so they goes in that direction. And here, when it it's finished the drum, the magnetic field of the drum start to fall down. Here you have a partition, a splitter here that you can move to separate the magnetics from the rest of the material. That's a simple way to separate. This drum is a similar drum, but it's a bit different. This is permanent magnet also, but in this case, the magnetic circuit is just about half of the drum only. And what is moving here is the shell, only the shell, the external one, and it arrives the vibrating feeder. You have here the magnetics and goes that way. The magnetics and the inert material goes in the other direction. And here you have also the splitter, you can move it. This one have a better contact with the material because you have a very small thin layer of stainless steel. So normally it has also, you have also a vibrating feeder normally. So you have a better separation normally than this one, but this one is a cheaper solution and it works well also. And this one is more usual for electromagnetics drums that they are of bigger diameter normally. They are typical for a shredder, for example, for cars, when you put inside a big factory a car to break it in pieces. So you have normally one of these big drums that has an external shell of manganese steel, very strong, very strong shell here. And normally it's fitted by the base, on the bottom of the drum, instead of this one that is on the top. And it also, this normally have like a changing polarity of the two changes of polarity of the magnetic field. So when you attract the magnetics, if for example it's a part of a car, you may have pieces that they get in the middle of the magnetics and the shell, some plastics, some textiles or whatever you have. So you make turn the pieces with this change of polarity, the pieces turn and this textile or plastic fall down, and you have a clean magnetic in that side. Okay. So also we have we manufacture eddy current separators, as my colleague said, that's for ideal for recovering aluminum, brass, copper, especially what is electrical, conductive, non-ferric materials, as they are widely used in shredders, wasting plants also, or recycling in general. Here you saw that in the video. I don't know if you remember the video of my colleague Carlos. Normally you feed from that part of the machine with a vibrating feeder, for example. And here you have a magnetic rotor that generates a magnetic field, and this magnetic field generates a currents inside each piece of aluminum, for example, what is called eddy current, with a magnetic field that is repelled from the magnetic field that generates that from the rotor. So it's repelled and it jumps, so you can separate and you can recover this type of material. Here you can see more in detail. So here you have a rotor, eccentric rotor here, and this will be, for example, aluminum that comes here, and when it arrives to the rotor, it generates eddy current that is if repelled, so it jumps to that side, or you have also here a splitter that you can regulate to recover here aluminum, copper, brass. So it's a different type of solution because this type of material is not magnetic. So it's a way to recover that. We normally supply that with a vibrating feeder that is shown here. We can put a hood for dust to reduce the dust, and also a chute here to have here the aluminum or copper from that side and the rest of material in that side. Okay. Okay, we'll continue. These are some installations of eddy current separators. You can have this is the material, it comes in that way. You have an overband here, and you can see we normally recommend to put first an overband separator to take out all the ferric material first, and after that you can separate aluminum, copper, other materials. You can see here that there is a hook here. You have a vibrating feeder in that way to open the material. It's good to have the material as much as much open as possible in order to cover the whole belt, so you have a better separation here. And you can have even 2-3 different separators in line, in parallel, sorry. Each one for one grand size of the material, because when it works better is when the size of the material is homogeneous, is similar, more or less. So you can separate in different sizes to have a better performance of separation. Okay. Also the transversal eddy current, that is a design from FELEMAMG, actually. It's special for really small particles of aluminium, copper. Use also eddy current separation as the previous eddy current separators, but in this case, because it's very small particles, the jump is very slow, so it has another system that makes it's like a step that it doesn't have to jump. It's just a step that the materials make to allow us to separate very small pieces of aluminium, copper, or brass. You can have it double, like this one, or it can be simple. It's modular system, so you can put many of them, one close to the other, to have a higher capacity. Okay. Also, another type of machine that we manufacture is a high-intensity permanent magnets, magnetic separator. We usually, as I said previously, with the eddy current separator, we usually supply it with a vibrating feeder to open the material. Also, here it's important to have the material as open as possible to have a good recovery. And here, this one is a magnetic, the magnetic circuit here, this roll. That you have here a high intensity and high gradient magnetic roll using permanent magnets. You can have up to 11,000 Gauss here. So you can attract weak magnetics material and high quality paramagnetics materials also here. Also you have here a splitter here that allows you to regulate it. And we have different sizes that can go from 200 millimeters width to 1.4 meters width, depending on the flow of material, the flow of the material that you need to treat in this case. Okay. And this is a high intensity SFAI separator of induced roll separator. This is the magnetics field here is produced with a coil, with electricity. And in this case, we can achieve, this is the most powerful one that we have, we can achieve up to 21,000 Gauss on the system. Here you have two of them, okay, and a double system. This system works in a cascade. I'll show you later. And you have a very high intensity field and high gradient magnetic field to attract paramagnetic minerals. These are minerals that have a very, very low, you are not able to catch these materials with a normal magnet. You need a very powerful intensity to attract these materials. There are many different materials that you can catch with this type of systems, such as iron oxides, manganeses, hematites, limonites, micas. There are different long list of materials that is possible to separate with this type of separator. Here you have a graph of how it works. We always we supply them. We can supply them with a double system with two lines. And we can have 1, 2, or 3 rolls in cascade. In this case, we have only 2. And the materials starts with a vibrating feeder here, a magnetic drum. We always supply a magnetic drum of medium intensity to eliminate any ferric material, poor ferric material, because here the magnetic field is such powerful that it's arrived poor magnetic material, it can damage the roll. So we have this magnetic drum as a protection here. And here you have also a splitter here to divide the magnetic paramagnetics, in this case, that goes that way. And here that way, that goes to the same exit here. And the inner material goes that way. And you can have also even another one to you can have even more purity at the exit of the material. And this one is double to have the double of flow rate. And you can, these also are modular, you can have 2 of them, 3, 4 of these machines, one beside the other. The various tools are for homogeneous material, grain size between 200 and 400 microns. This is very small grain size to make sure that you have liberate the particles that you want to separate from the others. Okay. Okay, so I already explained a bit about some of our separating equipment. Now I'm going to explain a bit of our magnetic lifting equipment. Okay. Just one second. So I will speak about round electromagnets for scrap or another type of applications. Rectangular electromagnets for plates, for example, electro-permanent magnets. Also, I will explain a bit the differences of electro-permanent magnets and rectangular magnets, as I said before, and special electromagnets, as I said previously. Okay. Round electromagnets, we have different series here. CM is the light series, is the typical one for scrap. Okay. CS is a steel mill, is a more robust type of electromagnet with a double bottom. The second one that is inside make it waterproof, so you can even put it in the water. We have a special, actually, we have a special type of round magnets that is possible to put inside the water also. Special for high temperature also, the CST, CSR with reinforced steel, with even more reinforced round magnet for breaking balls, for example, when the type of work is very, very, very heavy duty work. Okay. And also the special one for high amounts of light scrap. And X is the extra light one that we have also for scrap. Okay. FELEMAG is a single coil design. We have only one coil, very, very strong coil. We said that it's hammer proof. You can knock the coil with a hammer and it resists the knock of the hammer. 75 standard duty cycle, and it can be welded or cast iron casing also, and we can manufacture the winding with copper or aluminum depending what the customer needs in this case. Okay. Here you have some picture of different applications for electromagnets. Okay. For round electromagnets, scrap, for furniture also, to fit furniture. And here we have rectangular electromagnets. They are normally used for handling plates. They usually are supplied with a beam that allows to lift long plates. This beam can be fixed beam or can be like this one that is electro-hydraulic that allows, it's a telescopic beam that allows to open and close to adapt the beam to the length of the plates that you want to move. depending if you change the dimension of the plates, you can move it quickly to adapt to them. Other ways, more simple to do it is this one, for example, that use the hooks of the crane to open and close the distance between the magnets. Okay, it can be 4, 5, 6, depending on the length. You can have even 8 magnets if you need. The longer the plate, the higher number of magnets that you will need. Okay. And that is quite usual to have it in workshop or warehouses and some other places. Okay, I have to say that all the lifting equipment that we manufacture, we supply with electric cabinet, modern electric cabinet that allows to have a great control of the magnets with a constant current power supply, using a thyristor controlled by a microprocessor. Okay, that's improved the safety of the installation and also the life of the magnet. Also, because you have controls of the magnet temperature, you have also protection of overheating, short circuit, and overcurrent. So you have a very high control of the magnet, so you can protect the persons first. And also the magnet itself to have a long life for them. Okay. Also, this system for electromagnets includes battery backup systems to keep the load lifted during an average time of 20 minutes. In the event of mains power failure or malfunction of any phase, and also have a charger that controls in the beginning of each maneuver, you can control the state of the batteries, so it checks everything to make sure that everything is working perfectly. And also have different safety systems like pre-magnetization, that you lift the load at the beginning with just 65% of the magnetic power, and once you have lifted just some centimeters from the ground, you pass to 100% of the magnetic force, so you can handle the load without any problems and with total safety. Okay. So now I'm going to speak about the electro-permanent magnets also, that is similar, externally are very similar to these ones also, but internally are quite different, because they use here, we can have here one schematic of this type of electro-permanent magnets. There are 2 types, deviation, electro-permanent magnets, and commutation. Okay. As I say, externally are very similar to the electromagnets, sorry. But for example, the deviation electro-permanent magnets, you have the magnets here that they cannot change of the polarity. You have, I don't know if you can see, you have south here and north here, and it's always, that is defined when you manufacture this type of electromagnets. Okay. So when you don't need any current here, in this case, it works, it picks up the load without current. Okay. And you have a coil here that when you put some current here to this coil, you make a deviation of the magnetic field. Instead of going that way, to pick up the load, you make it this secondary system, magnetic circuit that goes in that way. So you deviate the magnetic circuit, and you can drop the load without problems. Okay, this is the system with the deviation electro-permanent magnet. There is another way of working with electro-permanent magnet, that is commutation, and in this case, these magnets here, you can change the polarity from south to north to south. So to pick up the load, you use these magnets with these permanent ones that they are fixed. So you zoom the magnetic power of this one with this one to pick up the load. And when you want to release the load, you change the polarity here with some pulses of current. You make some pulses of current. You can change the polarity here. So you make that this magnetic field is the same power of this one. So you don't have any power, any magnetic power here. So you can release the load here. I have to say that this type commutation magnets works in the same way that electromagnets. When you put current, you pick up the load, and when you release the current, you release the load. But always the load is lifted with permanent magnets in any times. Once you have done this pulse of current, you always have the load is lifted only with permanent magnets. You don't need any current, any voltage to move the load. So it has more security because you don't need backup batteries as the electromagnets in this case. The other one works in a different way. It works exactly the opposite as the normal electromagnet. So when you put energy, you release the load. So this normally is used when you are using an automatized system and not a manual system that is controlled by a person. That's normally this one APD system is for automatization systems, and this one for manual systems. Usually depends also on each situation. Okay. I hope that everything is, you understand everything I say. I hope so. This is some picture of electropermanent magnets. As I said before, externally is very similar to the other one, but internally is quite different. You have also for this one in shipyards, for example, a lot of them to move big plates for ships, for example. Okay. Okay, so now I'm going to show some special type of electromagnet that we manufacture also. FSRB magnet. This one are special for handle rod bundles, rod bar bundles. You define them according to the number of bundles that you want to manipulate in each lift. So you make it longer or shorter according to the number of bundles, and the number of magnets that you need depends on the length that you want to handle also. This type of magnets have a deeper magnetic field to make sure that unless you pick up the load with unless 60% of the diameter of each bundle is picked up with the magnetic force. So the straps here, the steel straps, are not suffering too much. Okay, so each type of load needs a different design of the magnetic circuit. Okay, it, for example, will be a quite deep one instead of other one. Okay, other type of load. So let's see next. For example, this one is a FBD magnet. This is a massive. It's for handling billets. This is a massive piece of iron here. So you don't need to be a very deep magnetic field to have a very big deep magnetic field. It's more superficial, this one, and it can be manipulated. This type of load can be manipulated with electromagnets or electropermanent magnets, but for electropermanent magnets only to have allows to handle cold billets. Okay, if you want to handle hot up to 600 degrees, it has to be with electromagnet, because one of the problems that electropermanent magnets have is that they don't allow too much temperature, because the magnets that you have inside, they don't allow you to hot to heat up more than 120, 150 degrees, okay, normally. Here also it's supplied with a beam and also 2 magnets, or depend the type of installation, you may need more magnets. But usually for this type of load, because it's a very rigid load, you will use 2 magnets only, okay. Other type of system, FPTM magnets. This is a special type of magnet, tripolar electromagnets, with moving poles. The poles, that is the part of the magnet in contact with the load, is like a slide. I don't know if you can see here. It's like a slide in different parts. It's adapted to the load, as you can see here in the profile bundle. It's allowed. It has the shape of the load, so you have a higher surface here in contact with this load, so you can lift this load without problems. That otherwise you will have more problems to load, because it's a difficult. You have many different shapes here to lift this load. Okay, so this is a special type of load also. Another type is for tube bundles. Here again, you have a deep magnetic field to reduce the effort of the stripes here. So, and also this type, for example, this one, you have this type of beam that you can move it around to move 2 bundles of, for example, 6 meters, 2 bundles at the same time. And when you have a long bundle of 12 meters, for example, you can move these 2 magnets and these 2 to have the line all together to handle 12 meters, okay, of tube bundles. Another type also for square tube bundles, also with an electro-hydraulic telescopic beam, and you can have even a more security if you want, using arms here, security arms to put here for even more security. Okay. Another type of system, electromagnets or electro-permanent magnets, also FBL or electro-permanent magnets, to handle unitary profiles. This is a special type of magnets that they are very narrow. This very narrow here, in order to be able to enter inside each profile, so you can handle unitary. Depending on the length of the profile to be handled, you will need, in this case, for example, you have 5 electromagnets or electro-permanent magnets, but you can have 2, 3, 4, 5, 6, 8, depending on the length, and they are also normally supplied with this beam also to handle this type of load. Okay. Magnets also for handle wire rolls handling here, as you say, in the Q surface, special type. Also, you can have 4 at the same time, 2 at the same time, with the beam and whatever you need to handle. Also, as I said before, always we supply the electric equipment to control them with all the securities. Special square and rectangular electromagnets, special for scrap handle. These are very big magnets of maybe 2.2 or 2.4 length each side of this magnet. You can have 2 of them for high capacity of scrap handling. Okay. Phase magnet also for turning the slab. That is something that they do in some of the steel mills. So you have a powerful magnet coil in the middle, smaller ones here. So you lift here up until you arrive to the main pole, and you can turn it around. Okay, there's many different types of different systems. Okay, electropermanents or electromagnet to handle steel coils on the flat surface also. Normally here you use 3 of them or 2 of them. This type of system, the most usual are electropermanent magnets, because normally it's a automaticized system usually. So you use electropermanent magnets of the deviation in this case. That's the usual one. And coils on the curved surface also with you can lift coils up to 30 tons with this type of electromagnets with a sensor of proximity in order to reduce any problems with the coils. So yes, there are different applications. I think I finished.